Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecule. Today's topic of discussion is on MCQ and the question is in front of you student. You have to say what is the major product of this reaction, and for that purpose 4 options are provided and one of them is the right answer. For your better understanding or as a clue you can consider, I'll tell you that it's about actually nucleophilic substitution. So I believe the question became a little easier for you. So I request you student, please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation, and don't worry, after some time you'll get the right answer. I believe you have tried by yourself. It's my turn to give you the right answer, and this question is inspired by this paper. You may visit if you want. Now, so this question, if you look at here, a reagent is given having 3 asymmetric center, point number 1, and another thing, reagents are trimethyl aluminium, and this is student, it's actually hydroxyl amine derivative. What type of derivative? So here one proton from nitrogen and oxygen is student substituted by methyl and only one hydrogen left, and we know such reagents are very much reactive because of this adjacent lone pair repulsion, which is nothing but called as alpha effect. So this makes this reagent a better nucleophile. That's why I told about nucleophilic substitution, and more specifically if I say it's actually acyl nucleophilic substitution, but how, what, let's learn in details. But before going to details student, it is actually trimethyl aluminium. So it's an organometallic reagent having aluminium, you can consider methyl carbon bond, and this is significantly polar also. So what you can expect in the first step? It is true that this aluminium center is Lewis acidic because it has 6 electrons. Okay, so Lewis acidic because of 6 electrons, but not only that, there is another story also. There is actually a free OH, and this OH bond is significantly polar, so you can expect that first there will be reaction between this oxygen, means this OH, and aluminium methyl group. So it will produce methane, and instantly you can think that these oxygen will be attached to this aluminium center, aluminium 3+. So I can draw it in a different way also student for your better understanding, that you can think that aluminium is coordinate attached here, aluminium 3+, obviously. Now there is lone pair also, so it can form chelate. Up to this, let's start. So the first step is actually acid-base interaction between the methyl group, which can act as a base, and this OH, and it produces methane. And here student, I will say that there is a aluminium 3+ bonding. Fine. Now in the next step, as I told, that these lone pair of electron will coordinate, obviously, because chelation possible. Not only that, till now this aluminium center is 6 electron species. Now after this chelation, it becomes 8 electron. So it means this chelation is favorable for aluminium stabilization. Now in this context, you can see that okay, this is the aluminium and this is one coordination, and obviously other groups are there, so I'm not going. So the aluminium 3+, and obviously there will be stabilization for aluminium. Now next thing, as I have taken these hydroxyl amine derivative, these are significantly nucleophilic, so it will attack where? Obviously this ketone side it will attack, and after that it will open and it will leave this part. Why it will leave? Now let's draw the leaving group. So this is oxygen O, this is nitrogen, and here obviously this is the benzyl group. Now here the negative charge, and these negative charge is resonance stabilized. How? It can push here, it can, so that's why it comes out. Second thing, if you think that sir, why nucleophilic attack did not happen from this center? See student, this part is actually a ketone, so more electron deficient compared to this. This is actually carbonate ester amide. Why I am saying this statement? So student, there is a lone pair on this oxygen as well as this nitrogen, so both can undergo resonance. So one resonance happen from this side, another resonance may happen from this and this side, so both ways. So this carbonyl carbon or carbonate ester carbon is significantly more electron rich, means less electron deficient compared to these ketone. Actually this is not ketone, it is actually amide. Here these nitrogen is in resonance with both sides, but this oxygen is the additional one. That's why nucleophilic attack will happen here, and ultimately what it will produce? It will produce this moiety. And obviously you can say that, sir, okay, it is true that it will form. Now there is a competition between this oxygen coordination versus this hydroxylamines oxygen coordination. So I am not going into that details. So okay, it will be produced, and this is also O minus. Now upon acidic workup or dilute HCl, what will happen? That these O minus will be quenched first, point number 1. Second thing, this aluminium part will come out, and ultimately this moiety will be produced. Actually this is also an amide, student. This is also an amide. Now question, is it stable compared to the previous one or starting? Yes, because in this case it is attached to this hydroxyl amine nitrogen, and these can donate electron density more to this carbonyl. So in this way this carbonyl carbon is lesser electron deficient compared to the starting one. Both are amide, fine. So this is actually the stability, and that you may consider this is the driving force also. So in this context you should know about this Weinreb ketone synthesis. What is this reaction? This reaction, if you treat this compound with RLI and RMGX, it produces ketone. So you can consider that from amide you are getting ketone, okay, and this is possible in presence of obviously RLI, organolithium, or RMGX, means Grignard reagent. Obviously here two equivalent of both reagent needed. Why? Because one additional this polar hydrogen is there, so that will consume one equivalent of organometallic reagent, and later second equivalent is responsible for, it will attack here, and ultimately the intermediate produced, means this, for example, lithium or magnesium, whatever you can say, is stabilized because of this chelation from this oxygen side, and at low temperature workup this ketone, getting of the ketone is possible. Not only that, if you use any hydride source, for example lithium aluminium hydride, then in the place of R there will be hydrogen, means these reaction can result in aldehyde. So that is the uniqueness of this Weinreb synthesis method. Now so what is the answer of today's question? In this case answer of today's question is obviously I guess option A. Okay, because in case of option B, nucleophilic attack happened on this carbonyl, which is not possible, I've explained. In case of option C, directly ketone preparation, no. Did I provide any organometallic reagent? No, gone. And why not option D? It's a ring opening. Ring opening, this thing is not possible, because it's not no nucleophilic addition, just hydrolysis of this part. It's not possible. Now if this question appear on your exam less than 30 seconds, how can you come to the right answer? Now you need to understand that where the reaction may happen. First of all, this is trialkyl aluminium. It is actually significantly polar reagent, so there is a high chance that these aluminium center will coordinate to this oxygen and remove one proton. Fine. Closer proximity, which one is there? Obviously this, so coordination will happen, and this hydroxylamine derivative is nucleophilic, it will attack, it will leave. Simple, very simple. And why this dilute HCl? Such that to remove all these basic reagents. So in this way you can get the right answer. Now if you don't know this, based on your common sense, how can you get the right answer? Now simple, which is more electron division? Obviously this nucleophilic attack will happen on this, and if this happened, it will leave completely, it will leave. So this option gone, this option gone, 2 gone. Now ketone, any methylating agent or methyl group, CH3 minus, did I provide? So not possible, only one option left. This is the right answer. So I believe in this way you can get the right answer properly. Now in conclusion, what you have learned, that amides are more electrophilic than 2-oxazolidones due to enhanced conjugation, and this case aluminium CH3 bond is significantly covalent, and this aluminium center can behave as stronger Lewis acid, and they activate carbonyl group for nucleophilic addition, because it's a sextuate, so it needs 2 additional electron to fill its octet. And next, Hydroxylamine is actually a better nucleophile due to its alpha effect on adjacent atom lone pair repulsion. And by the way, actually the nitrogen center is more nucleophilic over oxygen because nitrogen centers the electronegativity is relatively less, so it is more nucleophilic, so it can handle the positive charge better. Now Weinreb amide, actually it's a very good intermediate for ketone, obviously ketone and aldehyde. So preparation, but by the way, for ketone preparation using organolithium or organomagnesium Grignard reagent and low temperature workup. I repeat, low temperature workup that is needed. And if the nucleophile is any kind of hydride, for example lithium hydride, then Weinreb amide results in aldehydes. That's it's a versatile reaction method for synthetic chemist. Now this is the end of discussion. I believe this video will be useful. I thank you everyone for watching this video. If you really consider the content of my channel is worthy, then please help this channel to grow. So stay happy, stay blessed. See you in my next video. Bye bye.